Circle. What are you missing? Symmetry, if sine, then x-axis symmetry, if cosine is y-axis symmetry.
I said if it was sine, then it was
Okay, the first thing I want to talk about is symmetry, okay? And when we talk about symmetry, we're actually going to talk about symmetry for any type of polar curve, okay? So today we're going to talk about circles. Thank you. Today we're going to talk about circles and Rhodes curves. Tomorrow we're going to talk about lemmasones. Sounds fancy. They are. Sorry. All of them have the same symmetry. So I need to know, how do we know what kind of symmetry we have if there's a cosine? If there's a cosine in the equation, how do we know what type of symmetry we have? Marissa, would you write down? Okay. Oh shoot, I did sine first. Okay. If we have a sine in the equation, what kind of symmetry are we going to have? Y-axis, okay? We associate sine with vertical movement, right? When you did your circles, if you had a sine, it was either up or down from the pole. If there's a sine in your equation, you're going to be symmetric with a vertical. Sine, think of vertical. Okay? Cosine, we think of horizontal. If you had a cosine curve for your circle, it was right or left of the pole. Okay? So it would be symmetric to the horizontal axis. Does that make sense? Yeah, it's like all coming together now. Okay, I know a lot of you are trying to figure out what was happening with your Rhodes curves, sine versus cosine. Some of you are like, oh, it's like rotating a certain angle, which it kind of is. But the biggest thing is that we have symmetry, okay? Horizontal versus vertical. Okay, so let's talk specifically about circles. Okay, way back on the, I guess not way back, only on Monday, we talked about the circle, like R equals A. Okay, we didn't play around with that yesterday, but we talked about it Monday. What does that look like, R equals A? Eli, what does it look like? I know it's a circle. But where? Where's it centered?
Oh.
And how big's the radius? Okay. So our center's the origin, and A would be the radius. Okay. Now, you talked about these types of circles yesterday, right? You played around with A cosine theta and A sine theta. Okay. Grace F., what was the difference between a cosine and a sine circle? Let's talk about circles. Okay, we're not quite to Rhodes curves yet. So this would be like section 1 from your yellow sheet yesterday, where we had just a circle. Okay, so which one was up and down? Sine was up and down, cosine was left or right. So, if we had A cosine theta, we had a circle to the right. If we had A sine theta, we had a circle above. That's not very difficult. Okay? And A, Caleb, what did A tell us about our circle?
The diameter.
The diameter. The diameter is A in these circles. Okay. Now, what if I had a negative A here for cosine? If A was negative, what would happen to this circle? It'd be to the left instead of to the right. If we had a negative here for sine, it would be below instead of above. Okay. All right. We're going to practice graphing one. Now, if you want some of these to take into your notes when we graph these, you're more than welcome to come and get these anytime during the notes. Just walk up here and grab one, okay? It's not going to be awkward. If you want to just draw things in your notebook, that's up to you, okay? But the first thing we're going to draw is r equals -5 sine theta. And this one, I don't think you really need the polar graph all drawn out, okay, because it's just a circle. But you're welcome to that pile anytime you need it, okay? You know what I'll just do? I'll just put a pile at your pod, and then you can grab one when necessary, and then I'll pick them back up at the end. How does that sound? Then you don't have to get up and go. Okay, so r equals -5 sine theta. Callie, what are we working with here? We are working with the circle. You're going to see this little thing right here on every graph that you make. R max, R value. How big is the circle? It has diameter of 5. So the furthest away from the pole is going to be 5. Okay? Now, we know what this circle looks like, okay? We know that since it's sine, it's going to be vertical. And since it's negative, it has to be below the pole. So we know already that that's what the circle looks like. Now, I have some other questions here for you. The number of zeros, the zeros and significant points. Okay? When you graph, I want you to get into the habit of plugging 0 in for theta. That's the first thing that you are going to do. Now, answer me this. When we plug 0 in for theta, what do we get for our R value? 0. Okay. And then you'll notice when theta is pi over 2, we get a -5. That's why our circle stretches to here. Okay. And then if we were to plug in theta, we would be back at the pole. Now let's think about this. Zeros. When I ask you for zeros in like a polynomial function, you are looking for what to happen? Okay, it's on the axis. What about algebraically? What is 0? Y. We want y to be 0 algebraically when we're looking for polynomials to be 0. Here, when I ask for zeros, that means r is going to be 0. Our zeros occur at the pole. So when we drew this circle, 0, 0, negative, or pi over 2, -5, 0 pi. How many times did we touch the pole when we drew that circle? We touched it twice. We touched it when theta was 0, and we touched it when theta was pi. I'm not overly concerned about that happening with circles. I'm gonna have you do it in your homework tonight. But the real fun is gonna come when we're talking about zeros with a rose curve. But getting the idea for a simple circle is gonna help us set up for success with our rose petals. Okay. Where are you always going to begin your significant points at? 0. Okay. With a circle, just write 0, pi over 2, and pi, and boom, your circle is done. Okay? I also expect you to know what your circle is going to look like without having to plug points in, but those are kind of your backup. Those are kind of like proving that, yeah, I'm doing it right. Okay? Now, what most of your discussion was this morning was about rose curves. Okay? And I remember yesterday when you started graphing those rose curves, you got excited, right? They were pretty. Okay? So let's talk about those. We have these numbers, and it will be important for you to understand what these numbers mean. Okay? Okay. Before we get into the rose curves, I am going to take a quick time out and go over here to our problem of the day. I wanted to cycle back here. R equals 2 cosine theta. Chris, where is this circle? On the right side? And what is 2? Okay. So we know from that equation, this is our graph. Notice how this rectangular equation also matches that circle. Okay. So some of you might be able to get the rectangular equation without having to make all of the substitutions. Okay. Just an option. Don't have to use it. Okay? All right, let's talk about rose curves. We know and you shouldn't need to write this down, I'm just reminding you, that we have horizontal symmetry versus vertical symmetry. Okay? That number in front. A. Tegan, what does that A tell us about our curves? Okay, I like it. So you said diameter. I'm just going to change it to the length of petals. Since we're not talking about a circle, I'd rather not use the word diameter, but I understand what you mean. Okay, our petal length is going to be A. Okay, our max R value is going to be A. Okay. N. Maverick, what does N tell us?
N is the number of petals.
Okay. N is the number of petals. And is it as simple as there are N petals every time? No, that was kind of crazy yesterday, right? Some of you were like, I don't know how many petals they're supposed to be, but then when you figured out the pattern, it was, oh, okay, that makes sense. So Kira, tell us what happens with our petals.
If it's odd, I'm just N. If it's even, it's 2N.
Okay, odd, we have N petals. Even, we have 2N petals. Okay? So if it's even, we're going to double N, and that's going to be our number of petals. Okay? What's really happening, and whether you remember this or not, it doesn't matter. Okay? It takes us from 0 to pi to draw our odd number of petals. It takes us from 0 to 2 pi to draw our even number of petals. Because what's happening is if we go from 0 to 2 pi all the time, then on our odd petals, it just traces those odd petals over again. Okay? So if we go from 0 to 2 pi with like 3 petals, it would draw the 3 petals and then it would draw them again over the top. Okay? So what will help you when you are graphing is that we only have to go 0 to pi for our odd petals and stop here 0 to 2 pi to get all of our petals. Okay? Now, when we go to graph these, we're going to start, okay, we're going to do 2 examples, okay? We're going to do a cosine and a sine, and we're going to do an even and an odd, okay? There's going to be a big difference between cosine and sine rose curve, so I'm going to make sure we talk about that difference, okay? This is the one I want to do first. Okay, so talk quickly about at your pod what 3 and 5 mean.
So essentially, shape. Alright.
Giving you blue sticks.
No, that's not the that's the radius.
Okay, I have tape or I gave you some glue, okay? Okay, so our shape, Haley, what is our shape?
It's fine.
Okay, it's going to be a rose curve with how many petals? Good. So you're going to write rose curve. Let's look at that again, Haley. Which number do we need to look at for the number of petals?
Oh, 3.
Okay. But the 5, the number out in front, Courtney, what does that tell us? Okay, so we're going to have petals of length 5. Okay. Our zeros, we're always going to save for last. Okay? We're going to actually draw our curve and then we're going to worry about it. Yes.
So we just do just like some sure I think like 3 rows worth.
Oh, I want rows 3 petals. Okay, rows 3 petals. Okay. Now, the trick is to figure out where your first petal is, and then the rest we can do without plugging in numbers. Okay? If we have 3 petals that we're stretching across this circular graph, how far apart are those 3 petals going to be? Keep going with that, Grace. How are you getting those numbers? Okay, well, how many degrees do we have? Okay. Okay, so you can think of it in radians or degrees. We have 2 pi or 360 degrees that this rose curve is stretching, right? Well, if we have 3 petals, we need to divide that total number of radians by 3. So each of these petals are going to be 2 pi over 3 apart. Each of these petals are going to be 120 degrees apart. Okay? We can use that to our advantage. Hi. Thank you. Okay? So now, I say, start by plugging in 0. Okay. Richard, if we plug in 0, 5 cosine of 3 times 0, what do we get? What's the cosine of 0? The cosine of 0 is 1, and 1 times 5? 5. Okay. So at 0 radians, we go out 5. Hey, do we know where our pedal is?
How big is it?
Well, this is what we're going to do. Nick, how far apart are our pedals? Okay, so here we are at 0. 2 pi over 3 would be here. Another 2 pi over 3 would be here. Do you agree? So there are our 3 pedals. Okay. Marissa? Okay, so do you agree that from start to finish there are 2 pi radians in this circle? Like if we rotate this whole circle, there are 2 pi radians, right? Like there's 2 pi radians in a circle. Well, we have 3 pedals, so we're going to take that circle of 2 pi radians and we're going to cut it by the 3 pedals. So 2 pi divided by the 3 pedals. Okay? So now our first coordinate is here at 5, 0. We know what this is going to look like now. Okay? We know that we need 3 pedals. Now, I am not there looking over your shoulder watching you draw this. You draw it however you need to, but I'm going to show this again. Okay, this is how your calculator is going to draw. You ready? Are you watching my pen? It's going to start here. We have to go to the pole. Draw a pedal, go to the pole. Draw a pedal, go through the pole, and we finish. How many times did I go through the pole? I went through 3 times, which means we have 3 zeros. We have 3 zeros. Okay. We talked about zeros a moment ago, right? Maverick, algebraically, what needs to equal 0? Gosh dang, I did it again. Tiger, algebraically, I should not sit next to you. Algebraically, what do I need to do? R equals 0. Oh.
He said no.
Are you guys okay right here? Do you have a question? You got it? Okay. So R is 0. Okay, so now we gotta solve for theta. Well, we can divide by 5. That's good. 0 equals cosine of 3 theta. Okay, well now we need to know where the cosine is 0. Alright? Our angle is 3 theta. Right? So where is the cosine 0? Where is the cosine 0? Pi over 2? And 3 pi over 2. However, Nick, how many zeros do we need?
3.
We need 3 zeros. How many have I listed? 2. So I better keep going. What's the next place cosine of 0? 5 pi over 2. If I needed 5 zeros, I would list 2 more. But I need 3 zeros, so I'm going to stop. How do we solve for theta? We need to solve for theta by dividing by 3. So pi over 2 divided by 3 is pi over 6. 3 pi over 2 divided by 3 is pi over 2. And pi over 2 divided by 3 is 5 pi over 6. I'm going to come down here and also write the significant point of 0 pi over 6. For Rose curves and Rose curves only, I only need 2 significant points. I need to see your first petal, and I need to see your first 0. From there, you're just going to use symmetry to draw everything. There's no need for you to write down all those numbers, okay? I'm going to look at your graph. What do you think? Okay. Do you remember how I said the odd number of petals are going to stretch from 0 to pi? Right? Do you see how our zeros are between 0 and pi? Okay, you're going to notice that with your odd number of petals. It doesn't have to be something you remember, but if you notice it, that's what's happening. Grace, you have a question? Are you sure? Okay. Should we do another example? Okay. Let's do this one. Okay, we still have 12 minutes of class, we have plenty of time. Also, happy day, you're getting a worksheet for your homework. Okay. Tiana, what is our shape? And how many petals do we have? Okay, I like that you're looking at this number. But go back to our notes for what we said about n. And what happens if n is even? Okay, so we have 4 petals. Okay, so since n is even, 2, we have to double it for 4 petals. Okay, our max R value. Miranda, what's that going to be? Okay, so our petals are going to have length of 4. Okay, at this point we get to start drawing. We start with theta equals 0. Lindsay A, what is the sign of 0? The sign of 0 is 0. And 4 times 0 is 0. False. All right, what's the issue here?
Isn't the sign of 0 1?
No.
Oh no, sign of 0.
Okay. How do I know where to draw my first petal?
Don't, you gotta plug in another number.
Well, how about instead of plugging in a number to theta, we plug in a number to r. Okay, let's figure out which theta value we have our petal at. What number would we want to plug into r in this example? Why 4? Okay, our max R value is 4. So we need our petal length to be 4. Okay, well, we divide by 4. Now we have the sign equaling 1. Nick, I'll give you some redemption points here. Where is the sign 1? Okay. So pi over 2 would equal 2 theta, which means we have an R value at 4 when theta is pi over 4. There's our first petal. Okay. Here's the trouble, ladies and gentlemen. The sine of 0 is 0. So if you have a sine rose curve, you are going to have to determine where the first petal is by plugging in your max R value to R. So it's going to take you one extra step to figure out where your rose petals are. The cosine of 0 is 1, so it gives us where our petal is right away. But the sine rose curve takes a little bit more work. Now, this is nice. We know we have 4 petals. Okay? So Keegan, if we have 4 petals to stretch across, how far apart would they need to be? Perfect. We have 360 degrees to divide up into 4 petals, so they're going to be 90 degrees apart. So here's a petal, here's a petal, here's a petal, here's a petal. Now, please watch me draw this. I'm going to draw it like your calculator would. Okay? Our first coordinate is 0, 0, right? I need you to count how many times we go through the pole.
1,
2, 3, 4.
I didn't count the start.
Caleb, this is something that you were talking about earlier. Why are there 5 zeros?
Until they started 0, 0.
Okay, so Caleb, we got to this example, and Caleb was like, "There's 4 zeros," and I said, "No, you're wrong." We have to start at the pole on our sine rose curve, so we actually have an additional 0 because we start there, draw the 4, and end there. Okay? Now, I'm going to give you 2 minutes to see if you can find the zeros, or at least start setting up how to find the zeros. Okay? At 9:03, we'll talk about what you've done, but I want you to try to find the zeros without me first. Okay, we want R to equal 0 to find the zeros.
no. 0,
We don't need to go that far. I got this power.
I was telling my sixth brother, so it's really hard to get learned about these first.
Oh my God, I've never done
Okay, it's 9:03. Let's talk about this. We set R equal to 0. Which means we need to know if we divide by 4 where the sine is equal to 0. So 2 theta equals, the sine is equal to 0.
say zero, and then you just keep going every pi until you get to 4 pi.
So 0 pi, 2 pi, 3 pi, 4 pi. And why do we stop at 4 pi? Okay, we need 5 zeros. I wrote 5 of them. We'll divide by 2, so our zeros, we already knew 0 was 1 because we had it. But now we have pi over 2, pi, 3 pi over 2, and we ended at 0, so it makes sense at 2 pi. Okay. Thoughts? Okay, let's talk about a couple things. Odd petals. Odd number of petals stretch from 0 to pi. Even number of petals, 0 to 2 pi. Sine curves begin at the pole, so there's going to be one more 0. Cosine curves start on the polar axis, so the number of petals is the number of zeros. Okay? How many significant points do I expect? 2. One is a 0. One is a max R, or a petal. Okay? All right, let me stop this.